Okay, the lesson today is on parallel and perpendicular slopes. The objective is an I can statement always. I can use slope to determine if lines are parallel, and I'm going to use the symbols, or perpendicular. Okay, before we move on parallel and perpendicular, let's talk about the four different types of slopes. So slopes of lines here. Okay, we'll start off with the basic ones. Go ahead and make a couple XY axis like this. Okay, let's start off with the basics when you have a positive slope. Okay, our line will go from left to right, uphill, like so. Or likewise when we have a negative slope. Negative. This one's positive. Left to right, downhill, like so. Okay, I'm going to go ahead and flip to a new screen. I'm going to make two more XY axis, and we'll talk about the two that kind of mess people up usually. Okay, so what are the slopes when we have vertical lines, like so, or horizontal lines that extend forever, like this? Okay, vertical lines. Anytime a line goes straight up and down, it's when we have a number divided by 0. Okay? And anytime you try to take a number and divide it by 0 in the calculator, you're going to get an error because this is not allowed. So vertical lines, the slope is always undefined. And vice versa, if we have 0 divided by a number for horizontal lines, you're always going to get 0. So we say that this has 0 or no slope. 0 or no slope. Okay, scrolling on to the next page. Okay, let's talk about parallel lines now. Parallel lines, I would like you to write this statement. Parallel lines have congruent slopes. I'm going to put a little bubble around it because it's very important. I'm going to go ahead and sketch two lines with the same slope so we can look at them and identify that they're parallel on the same graph. Okay, go ahead and draw me an XY axis, and I want you to draw two separate lines that have a slope of 1/3. So it's going to look like this when you're done. Okay, and so I just made two separate lines here, the red one and the blue one. I gave them both a slope of 1/3. You'll notice that they both have a rise of 1 and a run of 3. Rise 1, run 3. Let's say m equals 1/3, m equals 1/3. So I know these two lines are parallel. And you'll notice they'll continue that same stair-step pattern and continue, and they would never intersect if they followed that. So your diagram should look like this. Okay? Give you a second, then I'm going to flip to the next screen. Okay, let's switch gears and talk about perpendicular lines. I wrote the statement over here. Perpendicular lines have opposite inverse slopes. I'd like you to put a little lake around that. And let's talk about what that means. Using variables, if I had a slope of a over b, the opposite inverse of that, opposite meaning we're talking about the sign, would be negative b over a. Okay, we also call this the opposite reciprocal. So go ahead and sketch an xy axis again, and we'll draw a couple lines, and we'll talk about opposite inverse slopes. Alright, I have my xy axis here, so I'm just going to pick any slope. I'm going to say I want my first line to have a slope of 2/3. So I'm going to pick any point on the y-axis here. I'm going to say, how about right there, up 2. And then I'm going to rise 2, run 3. Okay, and then I'm going to go ahead and make a line through those 2 points. Okay, so it looks like so. I'm going to say m equals 2/3. So I can pick any line perpendicular to this. I don't really care where it crosses the y-axis. But over down here I'm going to definitely identify what the slope has to be. So I would change the sign, negative 3/2. So I'm going to pick, again, any point, maybe, how about down here at -1. And from there I'm going to go down 3 over 2. And maybe I'll go up 3 and back 2 like that. And then I'm going to connect those points like so, and then you'll notice that these two intersect at 90 degrees. Okay, moving on to the next slide. Okay, let's do a couple examples. Example 1. Okay, I'm going to give you 4 points. A is 2, 1, B is the point 1, 5, C is the point 4, 2, and D is the point 5, -2. And the question is line AB parallel to line CD? Question mark. Okay, so we're going to refer back to our slope formula. I'm going to write it over here on the left, which is y2 minus y1 over x2 minus x1. But you'll notice I've got 2 separate lines I've got to deal with. I want to deal with these two, and then I'm going to deal with these two. Okay, so first thing I like to do is I like to determine what's my x1, y1. So I'm going to deal with line AB first. So above the 2, 1, I'm going to say this is x1, y1. This is x2, y2. And then I'm going to find the slope of that line down here. So I make a big division line, and I just very carefully put the correct number in the right spot. So y2 is 5, minus y1 is 1, over x2 is 1, minus x1 is 2. And I get 4 on the top, -1 on the bottom. So my slope for line AB is -4. Okay, now I'm going to go over to CD and I'm going to do the same thing. x1, y1, x2, y2, and then down below I'm going to draw a big division line. I'm going to very carefully plug the numbers in the correct spot. y2 in this scenario is -2, minus y1, which is a +2. x2 in this scenario is 5, minus x1, which is 4. On the top I get -4. On the bottom I get +1, which is also -4. So since they have the same slopes, the lines are indeed parallel. Okay, I'm going to go ahead and scroll to the next page and do example 2. Okay, example 2, again I have 4 points. L is -2, 2, M is 2, 5, N is 0, 2, and P is 3, negative 2. We're going to be a little more vague in this example, and basically I want you to determine, let's talk about the line LM and the line NP. And we're going to determine, are they parallel, are they perpendicular, or are they neither? So I'm going to go back to my slope formula again. And I'm going to do line LM first. So again, I have to say this is x1, y1, x2, y2. And I'm going to do the work right here, and I'm going to be very careful and plug the appropriate number in the appropriate spot. So on the top I get 5 minus 2. On the bottom I get 2 minus, but when I plug in a negative 2 here, this is going to change to positive 2. Be very careful there, that's the biggest mistake we see. And our slope for line LM is 3/4. So I'm going to leave it like that. Okay, now I'm going to do the same thing for line NP. I'm going to call this x1, y1, x2, y2. Down below here I'm going to make a big division line, and I'm going to carefully plug the numbers in the appropriate spot. y2 is negative 2, y1 is positive 2, so part of the equation is minus, subtracting. x2 is 3 minus x1, which is 0. And on the top we get negative 4. On the bottom we get positive 3. And when I look at these two slopes, I can identify that they are opposite sign reciprocals of each other, which means I just flip the fraction. Therefore, these two lines are perpendicular. And this would be my final answer.